equations. What is y when x equals 2, when x equals 0? Where would the graph of each equation cross the? Well, we're missing part of this problem, so we're just going to do the first two parts. So when x equals 2 in the first one, so we would do y equals 3 times 2 plus 15, so it would be 21. Then when it's 0, y equals 3 times 0 plus 15, which is 15. So same thing in the next one. So we're going to plug in 2. So y equals 3 minus 3 times 2, or 3 minus 6. So y equals negative 3. And when it equals 0, so y equals 3 minus 3 times 0, so y would equal 3. So negative 3 and 3 are the answers to that second one. Alright, problem number 17. Carmichael made a function machine. The inner workings of the machine are visible in the diagram. What will the output be in each of the following cases? So all you're doing is replacing x with the number. So if 3 is x, in this first one, it's 3 squared plus 2 times 3 plus 1. So you get 9 plus 6 plus 1, or 16. If we drop in negative 4, we get negative 4 squared plus 2 times negative 4 plus 1. So we get 16 minus 8 plus 1, or 9. And when we plug it in the last one, I'm not going to work the whole thing out, but we get 478.384, and it's actually repeating 384, but I'd give you credit if you had rounded it to 0.39, 0.38. The next problem says, does the temperature outside depend on the time of day, or does the time of day depend on the temperature outside? This may seem like a silly question, but to sketch a graph that represents this relationship, you first need to decide which axes will represent which quantity. When you graph an equation such as y equals 3x minus 5, which variable, the x or the y, depends on the other? Which is not dependent? That is, which is independent? Explain. So when you do that, y depends on x. X, because you're plugging x in and finding y. So then it says, which variable is dependent, temperature or time of day, which variable is independent. So the dependent variable is actually going to be the temperature, because we're going to look for the time of day to find the temperature. So the independent variable is going to be the time. So if we were to sketch a graph of this, we would put the time down here, the temp off to the side, and I made my graph kind of look something like this, where the temperature is going kind of up and down. You could have made it a little straighter, but usually there's ups and downs in the temperature throughout the day. The next problem says, Jill needs to cut a piece off of a 30-foot length of lumber. Create multiple representations, an XY table, graph an equation, for the function x values that are lengths of the piece Jill cuts off, and y values that are the lengths of the piece that's left over. Which representation best portrays the situation? Y, explain. So, similar to the first problem that we did, 0 would be 30, because that's how much she's going to have before she cuts anything off. So if she cuts off 2, she now has 28. If she cuts off, say, 5, she now has 25. So if we went up by, say, I think I went up by 5. 5, 10, 15, 20, 30. So approximately right there, a little bit less, would be where we would start. And then as we kept going down, it's getting less. So we kind of have some there. So our graph is going to kind of look like that. And it's actually going to stop. So like if we were talking about domain and range, it's going to have a shorter domain and range then, because eventually we're going to run out of wood. So our equation is y equals 30 minus whatever x is. And the best representation, I would say, is going to be the graph, because the graph clearly is going to show us where it can start and stop. The equation implies that we can have negative numbers, and so does the table. So you want to make sure that you realize that we can't have more than 30, We can't have less than 30. Okay. Make a table of the graph for the function of f of x is 1/2 x squared. Describe all the possible inputs and outputs of the values. So we can start with like 0, 0, because we know that's going to be our vertex. We know our parabola is going to go up. So next I would probably plug in 2, because I know that it's going to work out well. So 2 to the second power is 4. Half of 4 is 2. So it's going to be about there. Then let's plug in -2. It's also going to be positive 2, because -2 times -2 is positive 4, times 1/2 is 2. So I can tell that my graph is going to go like this. So then it says describe the inputs and outputs. It's really talking about its domain and range. So the inputs can be all numbers. But the outputs have to be x is greater than or equal to 0, because even when we plug in a negative number, it's never going to go below 0 for our outputs. This problem, there was part of it missing on your homework paper, so you want to make sure that you know that f of x was -2/3 x plus 3, and g of x was 2x squared minus 5. So we're going to just plug in for the first one. So we're going to do -2/3 times 3 plus 3. So we get -2 plus 3, which is 1. In B, we're solving when it's equal to -5. So we have -2/3 x plus 3 equals -5. So if we subtract 3 from both sides, we're going to get -2/3 x equals -8 times the inverse. These cancel. And I get x equals 12. In C, we're calculating g of -3 in the second function. So we're going to do 2 -3 to the second power minus 5. So I get 9, 18 minus 5, or 13. In D, we're solving when g of x equals -7. So we have 2x squared minus 5 equals -7. So we get 2x squared equals -2. X squared equals -1. Then we have to square root both sides. Since I can't take the square root of a negative number, x is actually undefined. Okay, and E I'm solving when it is g of x equals 8. So I get 2x squared minus 5 equals 8. Add 5. I get 2x squared equals 13. Divide by 2. I get x squared equals 13 over 2. Take the square root of both sides. So I get x equals, I need to make sure I put plus or minus. And I can just leave it as the square root of 13 over 2. But don't forget that plus or minus. So then in F, I'm solving when it equals 9. So I get 2x squared minus 5 equals 9. Add 5. I get 2x squared equals 14. X squared equals 7. So again, square root. But don't forget, it's plus or minus the square root of 7. So remember, when I take the square root, I can either get a positive or a negative. For the next problem, it says Jerry made a function machine. Below are 4 pictures of her machine. Note that these are all pictures of the same function machine. Find the rule. So I made a table to help me out. So an XY table. So when it's -1, it's also -1. When we plug in 3, we get 27. -2, we get -8. And 0, we get 0. So I can kind of tell that I'm going to multiply in some cases here. So I know that 3 times 3 is 27. So I'm going to guess I'm doing x to the 3rd power, which actually works for all of them. So my rule is y equals x cubed. These next problems, it says examine each graph based on the shape of the graph and the labels of the axes. Write a sentence to describe the relationship that each graph represents. Then state which axis represents the independent variable and which one represents the dependent variable. So this is actually the independent versus dependent. It should be pretty easy to figure out because the x-axis is usually going to be the independent. So like in A, I know that the independent is going to be the gas and the dependent is going to be the money. And I can say that the more gas I buy, the more money I spent. More gas I need, more money I spent. And you want to make your sentences a little clearer, but for time and space, the independent is age, the dependent is going to be height, and the older you are, the more you grow. Older, more height. And you can tell in this graph that it kind of evens out eventually. So the independent is the years, and the dependent is the ozone. So the more years that go by, the consumption gas goes down, so we're not affecting the ozone as much. So years past, ozone, let's say it's getting better. In the next one, independent is number of students. Dependent was the number of classrooms. So we can say that the more students, the more classrooms. Okay. And then E, what are the possible inputs of the graph in part D? What are the possible outputs? Well, in part D, the inputs are 0 to 120. You're not going to have less than 0 students. And then the outputs were actually just 1, 2, 3, and 4. You're not going to have part of a classroom, so we can't have like from another to another number. Okay. So problem number 24 considers triangles ABC and ADE at right, giving a convincing argument why they're similar to each other. So we can say that the argument is angle-angle similarity. So then we can say in A, y over x is n over m. And then in B, n over y is m over x. So problem 25, which is the last problem on this homework, is find the error in the solution below, explain what the error is, and solve the equation correctly. Show how to check your solution to be sure that it's correct. So if we're looking at this equation, the error is that they didn't distribute the -2. So the distribute -2. So the correct solution, so we can start with the one line that they already started. So we know we have 3x minus 6 minus 2x. It should be minus 14 equals 2x plus 17. So I'm going to simplify. So I get x minus 20 equals 2x plus 17. So subtract x's from both sides. I get -20 equals x plus 17 minus 17. I get -37 equals x. And then if I wanted to check it, which I should, I'm going to say, okay, I know 3, -37 minus 2. I'm going to check it kind of below just because of writing on here makes my finger a little big. So 3 times -37 minus 2 minus 2 -37 plus 7 should equal 2 times -37 plus 17. So we get -117 plus 60 equals -74 plus 17. So then we get -57 equals -57. So it does check out.